So welcome to the lecture number 21 in peer-to-peer networking MOOC course. In this lecture, we will be looking at the issues related to overlaid multicasting. In overlaid multicasting, the idea is that somebody is trying to send an audio or video stream, or for that matter any real-time thing, but there is only one source and there are many people who would like to access this. Okay, so there will be many people who would like to access this particular session. So one of the simplest example because of which we have been doing it is for transmission of live lectures. Okay, so that was the idea in Brihaspati 4, and the basic mechanism which we have thought of is that an instructor will actually give audio and video, and this audio, video and of course is screen capture will be available to everybody, and that people will be now accessing through this mechanism which we are discussing. And whenever if somebody would like to ask a question or something, they should be able to raise their hand. So that will be done through a signaling mechanism. So they have to send a signal which can go to the source, and source will queue it up, and the instructor appropriately can look at the signals and then actually give a confirmation. So this confirmation can be sent back directly. So this will be because they both will be knowing their endpoint addresses. Okay. So mostly the forward signaling from user to this will be coming through DHT route, but the reverse source can always tell the confirmation to the user that I am now confirming, and then you are allowed to interact. And then the audio video of the student will be essentially streamed directly over a point-to-point link, either using HTTP tunneling or through NAT or through a proxy. So it's a direct connection, and source will now actually mix all this audio video coming from him and his own interaction. These both interaction will be now available to everybody as a stream. Okay, so once it is over, he will be disconnected, and then source can take up more questions from the queue. So any one of the instructor can actually, any one of the student can interact with the student. That was the idea behind our design. But in general, this can be used even for a IPTV kind of implementation if we wish. So, but the question is, now we are not using in this case the multicast which is being provided by IP. There is no multicast use on IP layer. So what we are doing is, there is already a network and users are connected to this network. This is an IP network. So at application level, I am actually going to create a broadcast tree. Okay, so essentially source will be here, so it will communicate to this guy, may communicate to this can then communicate to this person, and so on. Okay, this guy may then actually can talk to another network on somebody else. So users are actually forming an overlaid network in this case. So how this will be done in a peer-to-peer system, that is the idea. So that's what I am actually now talking about in this lecture. So we can actually take care of lectures, or we can actually have conferences. All this actually can be done in this fashion. So this is a typical lecture scenario. Similarly, we can think of a conferencing scenario also. But normally, even in conferences, when a large number of people are there, there will be one person who will be chairing it. So he will be like instructor, and everybody can raise the hand, and then everybody can speak. So, but all the conversations are going to be, or everybody's views will be available to everybody else, and that's how they can actually come to a consensus decision. Or they may not come, but still they are become aware of each other. That's what is the purpose of any conferences actually. So how this will be done? So one important thing is that we have talked about DHT layers earlier, if you remember. So we have talked about a storage layer at that time. Okay. So storage layer was anybody who is providing in storage service to others, that will become participant in this storage DHT layer. So rest everybody can actually become a leaf node, but when you are a leaf node, there is no use because you can't actually use any storage service because you don't gain in the reputation. If you remember, that's what I had discussed in the one of the earlier lectures. Okay, so they need to be part of the storage. They need to contribute something. With same user, there can be multiple devices contributing, and henceforth he will actually get a bigger share of storage from others. So normally, whatever you contribute, you get roughly almost similar thing from the other side. Okay, if you contribute less, you get less, and this is basically we used a mechanism of reputation management system on another DST layer, which was a reputation management layer. Okay, which is different. This has not much load. This basically only some people, there is always for every node there is going to be somebody who will be acting as a reputation manager. Okay, and everybody who is using the service will keep on sending the information about the service being provided to the reputation manager of the server, and he will keep on updating the reputation of people. So when somebody is coming with a request to you, that time you check the reputation, and based on that you will provide him service or you will deny him. So that's what is the mechanism. We will also be using a similar mechanism here, but it will be in a different context. And we can actually prove that strategically there will be only one strategy which allows the people to cooperate in case of overlaid multicasting system. So now we are going to, for every media stream, so every lecture, so there is one lecture I am talking about, and these guys are going to listen to this. Okay, so guys who are receiving, so I call this a lecture. So this every lecture it will be a one layer. That's very important. There will not be one single common layer for all the lectures, but for every lecture I can actually prepare a layer. So in case of your DHT routing, so there will be a separate layer for each lecture or each live program, you can call it, or each conference or each TV channel. Okay, so separate for each lecture. And I should not use lecture now, I can call it a stream, but since I was doing it as an extension of an LMS, because we did Raspberry 3 LMS and the Raspberry 4 came, because there was some technical problems in that. In the sense it was not massively scalable. We require a lot of servers, and that's where I decided that we have to go to peer-to-peer way, because that's auto scales. So more the number of users are, the more the system will become better, and I don't need to invest in servers and everything. And that's more environmental friendly because I consume less energy, less hardware, no air conditioning required at the data centers. So we had discussed all this earlier. So first fundamental thing, each stream, media stream I should call it now. So that's the word which I will be using, media stream, will have a separate DHT layer. So every node who is participating, who want to receive this media stream, has to be part of this layer. So I can call it a layer for the media streaming. So every node participating or in the media session, so it can be a passive thing, you are simply listening, or once in a while you are interacting, has to be a member of this DHT layer. Okay, so he has to be member of that. So that what it means, every node which is participating will have one routing table and will also have one neighbor table, and the routing table will contain only the members which are, only the nodes which are the member of this layer. Neighbor table will also contain the nodes which are the member of this layer, but this will be basically based on who has got the best performance round trip delay time. Okay, round trip time we call it, RTT delay. So whoever has the least delay, that set will be maintained here, and this will be based on logarithmic partitioning so that the network will never get partitioned. There will be some node who may be participating in the layer, because anybody who is in the layer, so their node IDs will be present in these cases. Anybody who is going to be leaf node, so he is going to probably receive the stream, but he will be at the lowest end, but he will be actually having a poor quality, that's a problem. And there will be also, he will be suffering from the delay. If there is a TV broadcast is done through of a cricket match, so by the time the wicket is taken, the person gets out. By the time the last guy knows, actually there will be a delay. So because he will be essentially in this broadcast tree, he will be at the lowest node, actually at the lowest level, we call the leaf level actually. Okay, because these guys cannot garner the reputation. Their reputation will always remain zero in this system. We will actually, when I talk about reputation, then this will become obvious. So now every node will now look at the RTT. So it will keep on the way it was done with earlier DHT layers. Same way the routing table will be managed. Now with this, how the actually stream will be received. So most likely case is that whenever you are joined, you will join and you will come back to the bootstrap node first. So anybody can be bootstrap node. So you want to join this session, you will first of all find about the session actually. Okay. So you will find about the session. So this information can be kept in base DHT layer. Because this is not a permanent kind of key value pair, because this should expire after some time. So maybe the guy who is actually there is going to be a stream ID. So you will be getting through an advertisement or through a mail or some other source, some of your friend might be telling it. So you will have a stream ID. So stream ID can be simply a channel name. Okay, so you can say Star TV and then can be the stream ID. Okay, and then this stream ID you will pick up, and from there you will find out, you will compute the hash value of this. So again, this will be hash of this will not be copied. This is actually key. So as we had talked earlier, we will be having key and then copy 1, copy 2 kind of thing, combinations which will be there, so that even if the nodes dies off, these entries can be maintained. Though of course these are for shorter time, but still the same thing will be done. You will take a stream ID, copy 1 and compute the hash of this, and this will give you a hash ID. Using the hash ID, you can search in the base DHT now and go to the reach to the root node. The root node is supposed to be actually storing the stream ID and then corresponding what is going to be the bootstrap node to which you can connect. So bootstrap node will be the first node which will be in the DHT layer of the media stream. So most likely it will be the source node always, and maybe few other nodes which can come in. So media stream when gives it can always request few more nodes to go and then do it. Even if media stream is there, it's fine. So once that is there, so media's ID, node ID will be available here. So in that case, the current node will be first of all talking to the source and getting its routing table. So it will be also now making a neighbor table entry, and then further, because whatever entries which are here, based on that it will keep on optimizing, and after some time it will stabilize, and it may not be connected to root source node at that point of time. So it may be connected to different nodes in different partitions, and may be connected to a neighbor table, which is going to be the closest nodes based on RTT. Okay, so this part will ensure the connectivity, this part ensures the proximity. Okay, and that's what we are going to use now for creating our stream. Now remember, all these nodes are already actually interested in getting the media stream. That's why they are part of this DHT layer. So ideally when you will be joining, so anybody you will connect will always have a stream. So whether it's your routing table, whether it's in your this thing. So when you you actually optimize, you can find out which is the closest node and you can always connect to this. So currently I am not talking about the reputation or any other thing. I am assuming that everybody is cooperating. So somebody asks a media stream, and node will always is willing to give the stream to him. So there is no problem in regard to that. Normally I would like to receive the stream but would not like to give it, because I have to pay for uplink and downlink bandwidth both. Okay, so normally that is what is going to happen. I would like to only receive, I don't want to give it. And remember, there is no payment mechanisms which have been talked about so far. The financial things can be thought of in the system. We have been already working on that issue in B4 design, but currently we have essentially, if you are forwarding your stream to somebody else, you are actually paying in that sense, because you are now helping the network to proliferate. Okay, So you should get the stream because of that. So people have to be cooperative. So I am assuming currently that they all are cooperative. Now how the stream will be received? Worst case scenario that there is a set of nodes, they all join together at the same time. Okay, they all join together, but in that case what is going to happen is that they will be always first of all connected to some people who are already receiving this stream. So they will connect to bootstrap and they will start doing there. When this guy also join, at some point of time these may get connected actually. But in the beginning, in real life, when in actually implementation, you will never find that none of there is you can't there will not be a situation where none of these guys who are there in your routing table or neighbor table are receiving a stream. That will never ever be happening. So idea is very simple. With whichever whom you have the RTT which is least, you just send a request to him. He will now also maintain a children table, and then he will essentially start feeding you. He will say this is media stream I am getting, and these are the guys to whom I have to send. So there is a list of nodes to whom the media stream has to be given. These are basically packets. So you will start getting the feed. So this is pretty straightforward thing. So in the moment you connect to the source may not give it. So you may ask, but he say I am loaded, so he may refuse. So you can keep on asking from all other neighbor table or routing table entries, and at least one of them will start giving it. So once you start getting the feed, at least you are listening. But then meanwhile you can keep on updating your RT and neighbor table. And then what you do is you find out if there is a better candidate from the current person from whom you are receiving. If the RTT to the current person is very high, you will tend to choose a person with whom the RTT is least actually, because that is more efficient for you. So the idea is that the total number of average length of the links which are used in this broadcast tree, these sum total has to be minimized. Okay, that will lead to the most efficient use of resources. In a hypothetical case, I can take a scenario like this when we have a distribution happening. Okay, normally this will be a worst case scenario. This will never ever occur most likely. So then there are nodes who are connected but they are not receiving. So these dashed lines are the ones So there is a tree. So these guys which are actually already connected with dark line, they are already receiving a stream. So this guy are not. So but they are all supposed to, they will all be trying. So ultimately they will. So even if the last guy I am here and I have only these two as in my neighbor table or routing table, these are only entries which I have. So I can send a join request. So I am giving a hypothetical case. This actually will ensure that yes, things happen. So if it happens here, it will happen in the real life. Real life is far more simpler. Normally, any one of your neighbor will always be receiving it beforehand. If suddenly large number of people will tend to join, then of course it will take some time before the network gets built up. But everybody who will keep on getting successful will start getting the feed. Okay, it may take some time before it happens. Okay, so in your neighbor table, so I will just send a request, join request to both of them. Okay. But I will, whenever the request will come, I will tend to pick up from somebody who is going to have a better RTT. Okay, so that I will choose, I will actually put less resources from the network to use for this streaming system. So when this guy will receive, it will say I have received from here. Now in this case, this source will send a request packet. It's a joint request. This will always contain the source who has sent it. There is going to be a sequence number, okay, and there is going to be an age. So when this will be received, this will actually, I am just doing the broadcast routing, remember. So here I will make an entry that this guy has sent the packet. This is the last sequence number which I received, and this is the age. So whenever the age will expire, I will purge this entry actually. And if I get a fresh source in a new actually packet which is having better sequence number, I will replenish this edge. age actually in that case. But any packet which is going to have sequence number lower or equal will be simply discarded. So this ensures that duplicates are discarded. Now this guy will now send this packet to this side as well as to this side as well as to this side. Okay, that did, because it does not have a feed. If it would have had the feed, it would have sent the feed back directly to this guy by making an entry in case of your children table which would have been there. So in multicast we call it multicast routing information based IMRID, but I am calling it in a simple language a children table. But since it does not have, it can't use this because it's not receiving the stream, it will simply broadcast. Now this node receives this same request second time, so this also maintains similarly a broadcast table which will say that I have already received a packet from this with this sequence number, this is the age. This entry would have been there when this packet comes. This packet will be simply discarded because you have already received the same thing, and this might also have sent it in the same fashion, and this would also have been discarded here. But then there is a broadcast which is happening, so duplicates will be discarded, and this packet, this request packet will keep on moving, and every time this broadcast table entries will be updated at every node. So this is what is going to happen. Ultimately it will reach here. So here this might get discarded actually. So each one of these guys who are receiving feed gets it, and they suddenly they figure out that yes, somebody is asking for a feed. So what he will do is he will build up a children table here, and he will make this person's entry. So this will also start automatically getting subscription when this guy tries it out. There are too many nodes, even one guy doing it will also work, but most likely they would have already initiated and got the feed by that time. So when this starts, somebody will be there, he will figure out that who will get the feed, and from there he will get the feed for itself. So it will make a children entry that this is the stream ID and this is the children. So this guy's whatever is ID, that ID will be listed in the children table, and whatever feed is coming, that will also be broadcasted to him. Okay, from this side feed is not going to come because this has been discarded actually, being a duplicate request. Okay. So because it came from the same source. If this guy would have made a request, this would not have been duplicate, but this has come from here. So the basic idea is this need to get it to this particular guy. Okay. But incidentally in this case everybody will get the feed, whoever has asked for it. Okay. But of course this link would not have been there, this guy would not have got the feed, he might have to start a separate search for itself. Okay. So because this guy would have been not requested, so he would not have been given the feed would have to be taken by this guy from here actually. So but incidentally I have taken this link, so it is okay. So it is the request will go here and feed will come from this side. So this guy will also give a feed to him, this guy will also give a feed by making the entries in their children tables. Now here actually there are two feeds which are arriving. In this case this node has to figure out which guy actually has, remember these nodes are in their neighbor tables actually. So you send it to your neighbor tables, they will then further forward it to whichever nodes which are there in their neighbor tables and routing tables. Okay, so it will now look at the RTT of these nodes. So if the RTT for this is less, it will simply disregard this one and this one will be taken up. So the idea is very simple because a joint request was sent, so it created an entry in the children table. And what we have done is periodically you have to keep on sending the joint request if you want to receive the feed. In the beginning you do a broadcast and later on you can only send it to the guys from whom you are getting the feed actually. So this guy will not stop giving the joint request here, but will keep on giving it to this guy. So every few minutes or every half an hour kind of thing, this will get replenished, so entry will refreshed in the children table and it will keep on getting the feed. Same it will be coming here. So this guy will receive the feed, only one feed, so it will now, as already request was coming, so it will now create an entry in the children table, will send the feed here. Now if there are two feeds, this guy will find out which is having lower RTT. So it will pick up that person and the remaining will be discarded. So this feed will come from this side. It will stop sending the join here actually. Okay, once the join is not sending and this guy does not want the feed, which is not the case in our scenario, because everybody need to receive the feed because they are part of the same DST layer, same media layer actually. So this guy will still keep on consuming. Okay, there is no need to simply disregard the whole thing. In that case, of course, our strategy should have been very different. I would have used a different protocol, which would have been something like a protocol independent multicast in that case. Okay, but this is also fine. I don't have to maintain routing table here. That's a beautiful thing. So through a broadcast, I can actually create. And so now the feed will be start coming on this direction. Same way the feed will come in this way to everybody. So this guy now has to make a choice between whichever has got the lowest RTT. So this might discard this and this packet will come. And this guy now has to make a choice. So this will disregard this and this will come. So you have now started getting the feed through this particular route. Okay. And then of course, as time goes by, you are only going to send joins in this direction. So everybody will only send the joins in those directions only from where you are getting the feed. Next time you find out somebody is having a better RTT, you can send a join by identifying yourself as a source towards this direction. So this guy's got a better RTT than this, send a join and let's see what happens. Because he might also be receiving the feed after some stabilization. So you keep on changing this dynamically and ultimately you will have one single tree getting created. And this, if you look at the RTT on each of the links, sum total of RTTs for all active links will be minimum in this scenario. This will automatically get optimized. Now, it is possible that your neighbor table, if I am not using routing table, so remember each node actually has a routing table as well as a neighbor table. So maybe you can ask a question, why to use only RT? Why not to use RT actually, only use NT, neighbor tables, because they are actually proximity based thing. So I will actually always build up a best broadcast tree or multicast tree. But there is a problem here. If there are actually say 4 nodes which are very close to each other, and my neighbor table has only 3 possible entries, 3 maximum entries, so they will be only maintaining entries here. And actually somebody who is a feeder is sitting here. So I will keep on sending only if I only use NT, I will keep on sending only request here and I will never get the feed. So I should also send a request to RTs also. So all entries which are there in routing table. So that way you will always be ensuring that you are getting connected to the source, because everybody is using both RT and NT. So I will also be sending a request here. If I don't get any response from here, I will get a response from here and I get the feed. And because other guys are actually talking to me, I may start getting the feed to them. Okay. And once the feed is available, perfect. So now people will try to optimize based on RTT. Okay. So, but I will never be choosing, because I am getting the feed from here and I am giving it to others. Because nobody has responded to me earlier. Of course, I will find out that I am giving feed to these 3 guys. So I can't get the feed. There may be a situation that you are getting a feed from here. You give the feed to these 2 guys, okay, and this guy gives a feed to him, and I find this guy having a better RTT and also getting the feed. In that case, I can send a join, okay, and then the moment I will actually send a join so that I can get the feed, and he may even confirm, he may start sending the feed back to me. But then there is a loop, cyclic loop here. These need to be broken in this scenarios, because the feed can only come through this route. So one of the ways is when actually you are giving a feed, you should actually tell that when you are feeding to others and you are trying to join to somebody else, it has to be a disjoint path always. Okay. So of course in this scenario what will happen is when I join it here and I leave it this one, suddenly everybody's feed will get stopped. And in that case I have no other option, because this is not coming from anywhere else. So I will again start doing RTT thing and I will again connect to it. And that's when I should figure out that yes, it is not happening. Okay, but if I actually keep it alive and I keep on getting feed, I may get the feed twice. So whenever I am actually switching over, and by switching off the earlier feed I am not getting the feed, that time I should figure out this is an invalid thing. I should not use it. I will only use this one, and this will be simply disregarded even if its RTT is smaller. So I have to only do with the other tools actually. So that way actually you can actually break the loops, and there are various other methods also by which this can be done. So this is one of the methods by which this is possible. Now another problem which will happen in this scenario is that you are listening to one TV channel, okay, and now you suddenly want to go to another TV channel. Now that's a complicated scenario, because you have to now go to a different DHT layer, and there's going to be another DHT layer. So one of the ideas is channel you will be surfing say 1 to 2 to 3 to 4 and so on, because there is going to be a time overhead, after which you will be able to get the feed. So when you are doing this, you actually means you should actually connect to multiple DHT layer when channel surfing is happening. So while you are at TV1, I should actually have joined the stream and should have been getting a feed for some other DHT layer also. Of course, you are getting the feeds for all these layers, but you are only using this one. And when you are getting feeds for these, you might end up in also giving it to others while you are not consuming it. So these can be the scenarios which are feasible. That's the only problem which happens in this case. But this also can be taken care of to a certain extent. Of course, people won't mind. Anybody who is doing very fast surfing, for them, there is going to be too much overhead. They have to run too much DHT layer. So a lot of computing overhead and bandwidth will be consumed, which also happens even in case of an IPTV, because you have to subscribe to multiple IP multicast layers and you consume tremendous bandwidth when you are doing channel surfing. So normally whenever you are switched to another channel, you don't release it immediately, you actually wait it for some time, and when you are surfing that time you try to also subscribe to other one. So you have to look at the behavior, and then based on that at the receiver side you have to figure out a way so that the user don't feel this channel surfing delay which is going to happen in this system. So this is, I think, another complication which is there. So we have looked at the loops, we have looked at this. Now I come to an interesting problem, we call it free riding. Okay, so normally if I am getting a feed, I am happy because I am using it. Why I should give the feed to somebody else? This is consuming my bandwidth. And of course I am paying for it. I would not like. So normally people will have a tendency, the most optimal strategy for them is to only receive and see it. Don't give it to anybody else. But that way our network will never take off, because source only can give it to the limited people. Now question is why this guy should actually broadcast it to somebody else. I can make some mechanism by which there is an incentive to be here. Because if he is not going to be here, he may end up in here, and his quality of reception may be bad. He saves on the bandwidth, but his quality of reception will be bad because there will be more packet losses, there will be more paths. So let's look at this, how this can be done. So one possible way which we thought of in the beginning is that we can make a closed loop economy kind of stuff. So you are getting a feed, you are paying something. You are giving a feed to somebody else, you are also getting paid something. Okay, so whatever is the value which you are deriving by viewing this video, that's the only value which you are paying. So this value get added into this, so you are paying a higher to the source. Okay, so that actually means there is a currency transfer which is required, and digital currency transfer requires something like a blockchain if you have to do it reliably, or you require some central banking where whenever the transactions happen, both the entities will send the request and the bank will keep track of who actually holds what amount of currency at what point of time. So that could be the only way. But the only problem which we see in any economic system, normally there will be a closed loop economy which exists always. Okay. So for example, there are many entities, so you are transferring some value to him, so he will transfer the currency to you. In turn, you are getting some value from somebody else, you are transferring the value to him. So the currency circulates actually. Currency circulates in the economy and the value circulates in the difference. So everybody contributes. Somebody who does not contribute gets bypassed, so value goes directly and currency also goes directly. This guy remains poor now. It is possible there are some nodes, so some of the currency, some part of the currency or value passes through this way, but this is a very small amount. But the sum total of this has to be equal to sum total of this. So in fact, when you want to reach, you want to actually route maximum amount of this flow, economic flow through you, then you will become rich guy actually. And of course, if you are start storing the resources, then there is an issue because they are being taken out of the flow. So economy actually contracts in that situation. So this is also not encouraged. Now, only problem here is that there has to be conservation of currency. So total amount of currency has to remain same. So currency cannot be destroyed, cannot be produced. And so implementing blockchain will be much more cumbersome. So we have thought about it, and ultimately we came up with an idea that we can use reputation in this case. Okay. So depending on a certain desired behavior, we can actually modify the reputation of the person. So you have a tendency to gain a reputation because with higher reputation, you have an advantage when you are interacting with others. You always act as if so that you gain higher and higher reputation, and that way we can actually give an incentive, and people will be willing to now not only receive the feed but will also give it to others. So we have thought of a way of actually doing it. So though we are actually still investigating this, how this can be done, but I find this is a far superior method. It's actually simpler to implement, and I don't have to maintain this conservation of currency principle here. Okay. And then of course there has to be equitable distribution, so everybody has to, whatever is spending, that much he need to earn in this scenario. If that does not happen, somebody will go out of the network. Somebody will start dominating. That's not desirable for our system if you want to build up a peer-to-peer network. So the way it is going to happen is that if a node, we will actually maintain another DST network. Remember in a storage DST, when we had talked about storage layer, we have talked about storage DST also. And then we have talked about the reputation DST at that point of time. So reputation, for that we will have a separate DST. The same actually reputation DST can be used here also, but this is a reputation regarding the overlaid multicasting. Now why we, so this reputation DST will have nodes, some nodes will be there. So every node who is there, who is actually participating in my media DST layer, so every node will have a node ID. So I can actually take this node ID and then I can compute the hash of this. And this hash of this node ID, even without that this can be done, but I would like to always do hashing because that gives a randomization. And then find out a root node for that, for the hash ID. So you get the hash ID here. So this guy is the person who will be holding the reputation of this person, this node. So the rule is very simple, that whenever a node is supplying, so some node is receiving. So whenever this node receives, it will now send a message to this responsible node in the DST layer. So every 5 minutes it can send only one message. So we have a restriction of that kind, every 5 minutes one message. Okay, and this message will come here. So it will now update the reputation of this person. So reputation is going to be something which is going to change with time. So reputation at time t is this. So I want to find out, let this current time be t. So reputation at earlier time. So for example, t minus tau time, at that time the reputation was updated for this node. Okay, for this particular node I am talking about. So there is going to be RT minus tau. So this reputation should decay. So we are always taking a concept, if you have a reputation this, if you are not gaining in the reputation, reputation will decay with time. If some positive message comes, the reputation updates. If more positive comes, the reputation updates, otherwise it keeps on decaying. Okay, so if you are not active, you are not participating, you are dead. You have to start from bottom always, and you have to gain the reputation by becoming more and more cooperative. So this reputation will decay, so I will define a parameter alpha. So what this parameter alpha should be, we have to decide appropriately. I will only give what happens if the alpha is small or what happens when alpha is big. So what will be a tendency of node depending on this alpha value. So this has to be a network constant. So this will be decayed reputation which will come. Now because this node has actually given an update to you, so I will say this reputation will always be 1 because of this thing. And I can now do a weighing actually. So I can have 1 plus e raised to power minus alpha t. This will give me a new reputation value at RT now for this particular node. Okay, for this node. Now this value will always be less than 1. Okay. But interestingly, the problem is that this guy's reputation is small or high. Based on that, my reputation, if somebody has having a higher reputation and he is getting a feed from me, I should actually have a higher increment. So I will have a tendency to give my feed to a person with higher reputation. So that's the actually advantage which you have. If we are going to have higher reputation, you have a chance of getting a feed from somebody else who is having higher reputation than you. So you actually can be closer to the source. You will get the things in time. You will get more number of packets. There will be less amount of loss because more number of hops are there, more the loss can be there in the packets. Remember, in the media, we don't actually use TCP. We use packets. It's like UDP things, which are UDP packets which are transmitted. If they are lost, they are lost. So you may be getting a lot of media. So if packets are lost, you will get a kind of a jerks in your audio and video media which is being played back. Okay. So it's always desirable to be towards closer to the source, which is going to have highest reputation actually. Okay, because you are going to get it and your reputation is higher. That's why he actually gains a higher one. So we change this formula further. So we change this formula to now RT will be equal to RT minus tau e raised power minus alpha tau plus. I will now put up an exponential formula and I will put A, and this will be the reputation of the receiver, the guy who has sent me the update. So this is reputation is now RR. Okay. So this, when it goes, so I will use this reputation. I will multiply it by 1. And then I will do e raised power minus alpha tau plus e raised power a RR. So this value will always be less than or equal to 1, and it will always be greater than 0 obviously. Okay. So it actually means if this guy has a higher reputation, I will have a higher gain. If this guy has a lower reputation, I will get a lower gain. As a consequence, now what is going to be the best strategy for a node? Okay, node always wants to get a feed from a higher reputation. That's very important. He can only get it if he actually has a higher reputation, because when somebody is asking me, I am going to choose somebody with a higher reputation only, so that I will have higher gain in my reputation because of this mechanism. Okay, so for you, for anybody to gain a higher reputation means he has to forward. Otherwise, he can't gain higher reputation. So people who are at the leaf node, they will at the least amount, they will have 0 reputation because they are not forwarding. Given an opportunity, they will start forwarding as soon as possible somebody asks, because they gain in reputation. So then now, within whatever options when they have in their neighbor table, if they find out, note that in our situation, you cannot connect to anybody. You have to only connect to somebody who is in your neighbor table. Okay, I am now also trying to optimize on the round trip time. So I have a limit on how many can be there. So I will pick up somebody else who has got a higher reputation. I will tend to connect to him. If he accepts, it's fine. I get connected to him and leave this guy. So this guy's reputation actually then over time goes down because he is not giving the feed to me. Okay, but I am not sending update about him. Now there can be a situation when some node says, okay, I am actually getting the feed. Why I need to send the update about him? So he becomes a rogue node. He is a malicious. So this node is not sending to the reputation server. He does not send the message. So we also do it because we have to apply that 5-minute rule. So every node, every reputation server will maintain a queue of, say, how many messages were received from the last, say, 30 minutes regarding the updates. So anything which is a duplicate coming from the same source, simply discard it. So it has to be actually every 5 minutes. Okay, so this need not be 30, this can be 5 minutes only. So every 5 minutes, if somebody tries to send, say, 10 requests within one 5-minute frame, so all remaining 9 will be discarded, only first one will be kept. Okay, so I can always go and check periodically that whether the guy whom I am feeding is sending the updates or not to my reputation server. This can be checked by this guy. If he found it's not doing, he can simply kick him out. That's it. So if you are not cooperative, you are doing malicious thing, you are out. So now your reputation is 0, you have to find out somebody else, and you have to be honest. If you are not, you can't get the feed. So this strategy, this game theoretic, technically what we have done, we have actually proven that there is no better possible strategy for him to operate in the network except to be cooperative and forward whenever it is feasible. Otherwise, you end up becoming a leaf node. You will go lower down in the topology. So the guy who is closer to source will actually have higher reputation. Okay, the guy who is in the bottom will be having lowest reputation. So if you are not cooperative, so you will not gain reputation, and henceforth you will end up in going down to the bottom. Okay, of course, this we don't have a dynamic topology in the current scenario. We are actually using neighbor tables and we are trying to still adhere to whatever is coming. So we optimize on the round trip time also. But yes, we can actually now add more flexibility further, and we can say that if I get more information, because every guy there, we are also exchanging neighbor tables. When I get neighbor tables from my neighbors, I can actually use that particular additional information also to try to connect to them actually. So they become my neighbors. So I can now make a what we call another neighborhood. I can actually now make what we call a separate tree structure distribution. So where I can actually say who is going to be my feeder. So feeder node, and then of course whenever my neighbor's table is coming from others, I can find out if somebody is a better feeder with higher reputation available and is willing to feed me, I can just simply keep on changing my feeder. And this feeder also I can use to get what are his neighbors actually, if he is willing to share. Otherwise anyway I will keep on doing it again and again and again. Okay. So but this is the way we can actually create an overlaid multicasting system. So this is going to be pretty much massively scalable, and you have to understand that this is very lucrative, because even if I do only source only gives it 2 guys, these 2 guys gives further to 2 guys, and this is the first hop, this is the second hop. By the time I do 64 hops, okay, may say 63 hops, so I will be having a huge number of nodes which can get the feed. Okay, so this is actually is extremely large number, because what I am doing is I am doing this 2 raised power 0, 2 raised power 1 plus 2 raised power 63. So this value will become actually 2 dot so this is going to be right, it will be 64. Total number of terms will be 64 into this divided by 2. Okay, so this is going to be a pretty huge number actually. This is going to be, I have made a mistake here. This has to be s, so multiplied by 2. So this will become this total number of nodes which will be there is 2 to the power 64 minus 1, which is extremely large number. So almost every computer on this earth, if it is being counted, this number is going to be still larger than that. So with 64 hops, I will be able to actually stream it to everybody. So that's actually become, I think a very nice system, and can be massively scaled up without using any servers. So I don't need high-end servers to actually start feeding each other. Okay, feeding all the users, and users start paying. Only thing the way you are paying is you are forwarding it to others, and by reputation mechanism you are trying to reduce your delay. The lower reputation guys will be at the bottom always. Okay, so with that we close this particular lecture. In the next lecture we will look at another interesting topic. Thank you.